Okay, Assalamualaikum warahmatullahi wabarakatuh. How is everyone?
Sir?
Can you? Okay, so good.
Low voice, sir.
No voice?
Yes.
There is no voice. What about now? Is it still low? My voice still slow.
Yes.
How is it now? Still the same. What I do then? So you still cannot hear my voice? Not yet. Not yet. So let us try to solve this problem. What about now? Can hear but low. Bagus.
Yes,
Better.
sir. Yeah.
Okay. Let me just try to set up this thing. So now it's clear, eh? Okay. So I hope everyone is doing well. Based on the previous quiz, I've shown to you on Monday, and also from our discussion last Monday. So what we're gonna do today, I hope to be able to finish as much as possible. So let me just start presenting. So let's just try to finish up from chapter 9. Chapter 9. Okay. So what is so the last section of chapter 9 is basically the applications. So how do we apply this concept of derivative, limits, and differentials in business and economics? So if you just recall the technical definition, so we are basically investigating the change in two things. One thing is within our control, which is the input or the independent variable, like the number of worker and number of hours that you spend studying. And if we were to change that, so correspondingly, our output will also change, or the dependent variable will change. So your grade or your profit will also change accordingly. So in the derivative, we are interested to analyze those change. So this would be a direct application of this concept of derivative. So we're gonna basically look at marginal cost, marginal revenue, and marginal profit. So these three, okay, technically they are the same, but they have, when we apply the concept of derivative, it will be the same concept that we are applying again and again. Okay. Um, so, so let's start with the concept of cost. Okay, let's start with the concept of cost. So we have X. So if X represent the number of units of product produced, so this is quantity, quantity of product that we produce within some time interval. So let's say we define total cost, which is in monetary value, ringgit or dollar. can be represented by this function C of x, where x is our input. X is the number of product that we're going to produce. Okay. So logically, if we were to produce more, what would happen to our cost? It will go up, isn't it? I mean, the more that we produce, we have to incur higher costs. Okay. So that's more or less the basic relationship between X, which is the number of product, and total cost. Okay, total cost. Now, what is marginal cost? So marginal cost would be the derivative, would be the change in total cost when X, our input, changes. Okay. And then we have revenue, which also depends on the number of product that we produce. So that is why revenue is another dependent variable that depends on X, which is our independent variable, the number of product that we produce. If we produce more, if X goes up, our revenue is also expected to go up. Okay. So marginal revenue, okay, is written like this. R prime of X. What is the change in revenue? The change in revenue when X changes. When X changes. Total profit would be revenue minus cost. So this will give us profit P of X, which also depends on X, the inputs. So marginal profit is written like this. So since we have a function, okay, a function which consists of two terms, two functions. So if we want to find marginal profit, we apply one of the theorems before. So we simply differentiate revenue function. We get the marginal revenue, and then we minus marginal cost. Okay. So marginal profit basically equals to marginal revenue minus marginal cost. So what is the relationship between marginals and derivatives? So marginals, okay, so let's take, for instance, marginal cost, okay, is interpreted as the instantaneous rate of change of cost relative to production at a given production level. So take note of this term. So at any given production level, so we need to have a specific value of X. Because marginal cost may not necessarily be constant. It may not be the same. Perhaps when we produce at a small number of production, perhaps the change, the instantaneous change in cost is smaller compared when we already produce a lot, or vice versa. So it is all about the instantaneous rate of change. Uh, So the change that happened basically instantly at that moment. So how do we basically how do you understand the word instant? Instant happened basically at that moment, or basically from point 0 second to 0 point perhaps 0.001 second. So within this small time interval, to some people this is instantaneous. Well, to some people, maybe I don't know, like instant noodles, Maggi, right? So 2 minutes would be instant food. Okay, well, whatever it is, we are basically investigating the change in one of the variables, which is the dependent variable, the cost, when the other variable change instantly. Okay, within such a small time interval or by a very small amount, which is nearer to zero. So this would be the basic relationship between marginals and derivative. Because what do we do in derivative? In derivative, we simply find the change, right? If you remember, f of x plus h, okay, or delta x minus f of x divided by delta x. The change in x, and then we make the change in x to be as small as possible, right? So when we make the change in x to be as small as possible by a very small value, or by within such a small time period, so that is what we term as the instantaneous rate of change. The change that happened instantly. Okay, the change that happened instantly. Okay. So what is marginal cost and exact cost? So let me just try to see. Having a bit of problem with the Wi-Fi here. You are all still with me, right? Because I just have another dummy account that I opened, but then I lost the unfortunate the Wi-Fi connection, even on campus. Okay. Um, so let's say we have this a cost function. Okay, a cost function CX. Okay, which is the total cost of producing X items. Now the exact. Okay, so take note of the word exact. Okay, the actual additional cost of producing one more item is given by this, right? This is where we are changing from X, which is a given level of production, and we simply want to add one more item, one more product, one more unit of output. Okay, so as we add one more unit, so our new cost function, okay, will be Cx plus 1 minus Cx. So this would be the exact additional cost. Okay, exact additional cost. Now this is also applicable for revenue and profit. Okay, so any additional revenue or additional profit from one more unit, we simply add this. Okay. So let's say we have this example, the cost analysis. So we have a cost function. Okay, a cost function which is like this. So this is the weekly cost in producing X number of tanks. Now, first task, we need to find the marginal cost function. So how do we find the marginal cost function? So we simply differentiate. Okay, we simply find the derivative. Now, this consists of three terms. Three terms. So how do we then differentiate? So how do we find the marginal cost? Can we do this together? So C of X, C prime of X equals, what is the change? 10,000 would be 0 because there is no X. Okay, there is no X. So regardless whatever we change the value of X, this 10,000 will not change. Plus 90, right? Minus, so 2, we bring it to the front, multiply with 0.05. So this will give us 0.1 X. Now this is our marginal cost function. Okay, marginal cost function. Okay. Now, find the marginal cost at the production level of 500 tanks per week. So let me just rewrite the. So this one we have already find the marginal cost C of X, which equals 90 minus 0.1 X. So now we want to know what is the marginal cost of producing 500. So what do we need to do? We simply substitute this 500 into X. Okay, so we're going to have C prime of X equals 500 equals 90 minus 0.1 multiply with 500. Okay, so we're going to have 40, right? This is 90, this is 40. So we have $40, which is our marginal cost at the production level, 500 tanks per week. Now, how do we interpret the result? Okay, so this is how we interpret the result, this $40. What is the meaning of this $40 marginal cost? So basically, we are saying that when we already produce 500 tanks, okay, if we want to add one more tank, so each additional tank, okay, would basically increase our total cost by $40. Okay, so when we already produce 500 tanks per week, the total production cost would go up, okay, at the rate of $40 per tank. So if you were to add one tank, so our total cost would be 540. Okay, 540. So each additional tank would cost us $40. Okay. Now I hope this simple example is clear to everyone. Okay. So moving on. So let's say we want to find the exact cost of producing the 501 tank, the 500 first tank. So the solution would be, okay, of course, I mean, you can always uh, we apply the previous concept, this one, the exact additional cost for part D, right? This one. So we simply find the total cost of producing 501 minus the total cost of producing 500 tanks. So that's basically what we are doing here. So first of all, we find the total cost of producing 501 tank. Okay, so what do we need to do? We simply substitute the value of x with 501. 501. Okay. Now, the total cost of making 501 tanks is given here, 42,539.95. What is the total cost of producing 500 tanks? So we simply substitute 500 into here, into x. Okay, so we got 42,500. Okay. Now, can you see what is the exact cost? Now, the exact cost, we simply find the difference between these two. Okay, so the exact additional cost of producing the 501st tank is actually $39.95. Okay, now what is the, so 39.95, this is the exact cost. Okay, and we obtain this when we do this analysis, when we really find the difference between the two. However, now doing this may incur additional time, isn't it? So that's why, I mean, if you compare that 39.95 and $40, the difference is not that much, right? It's only 5 cents different. And this is a good thing about using derivative. Remember last time, the difference between delta y and dy, these two, this is actual change in y. This is the approximate change in y, approximate change in the output. And using derivative would save us more time because we only need to find the derivative, and then we simply substitute the current level of production 500, and we got $40 marginal cost. $40 marginal cost compared to 39.95 is not much different. So that's why in calculus, derivative is a good approximate of the actual change, especially when the change is very small. The smaller the change is, the better approximation that we are going to have. Okay, now, so this is the graphical representation of what we have done. So from 500 to 501 tanks, isn't it? In the previous example. So as we add, as we produce one more unit of tanks, so this is the change in X, where we have added one more unit of tank. So we move from X to X plus 1. Okay. Now, given that this is our the blue curve, this is our actual cost function. Our actual cost function. Now, the change in total cost is given by this, where this is our CX, right? This is our output, our dependent variable, okay, C of X. Okay, the cost function depends on X. Now, at this, so as we move to X plus 1, this should have been our, so this 2 is the change, the actual change, right? This is the actual change, delta C X. The change, the actual change. So this is the actual. Okay, this is the actual. X. Found it a bit challenging to write. Okay, actual. But okay, so but there is another way. So when we apply the concept of derivative, we simply use the original point at 500, okay, at this given level, and if we can find a tangent line, if the limit exists, okay, in this case, for this function, the limit exists, so we can find a slope, the slope of we can find a tangent line at x, a tangent line where there is a straight line that touches only one point along the curve, and the slope of this line, the slope of this tangent line would be a good approximate of the actual change. So this is, so C prime of x, which is the derivative, as you can see, it is actually a bit higher. Okay, a bit higher. So in our example, the difference is about 0.05 cent, isn't it? But 0.05 is such a small amount for a so if we so this is, as you can see, there is a gap. So this is the approximate where we apply the concept of derivative, and this is the marginal cost. Okay, this is what we term as the marginal cost. Okay, and it is a good approximate as long as we make the change to be smaller. If you were to make the change to be smaller and smaller, so imagine if the tangent line, right? Okay, so it will be, so the gap would be smaller and smaller, isn't it? As we move to the left, the gap would be smaller and smaller. So that's why when the change in x is smaller, then the derivative would be a better approximate of the actual change. Okay, so I hope so far the explanation on the application as well as this graph would already be more than enough to make you to understand the concept of derivative. So the difference between marginal cost and exact additional cost, they should be they should be a kind of a exact additional cost. When we This is the exact additional cost when we add one more unit of quantity produced. Okay. So this give us the theorem one. So this is what we term as where we use this wiggly equation symbol to mean that this is more or less equal, or they are good approximate. They are a good approximate. So marginal cost, okay, would be a good approximate of the exact cost of producing the X plus first item. Okay. Okay. Second example, I'm gonna leave this to you because this is basically the same application. So from 100, okay, we want to find the exact cost of producing 121, so we can do it. So this is how we do it. From 121, the total cost is 25,221.80, and this is the total cost of producing 120. These are all total, 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 total. So how do we find this exact cost of the 121st bicycle? So we simply subtract this. So we find the additional cost, which is 101 and 80 cent. Now use the marginal cost to approximate. So if we were to use the this so let's try to do this. Find the Can we find? Yeah, of course we can find the marginal cost. So how do we find the marginal cost here? So marginal cost, the C prime of x is given by, so 10,000 is 0 plus 150 minus 0.4 x. Okay. So instead of so now next would be we simply put x equals 120. So plug this in to here. Okay. So what we'll have is that 102. So 102 compared to 101 and 80 cent. Difference is 20 cent. Okay, 20 cent. So it is a good approximation of the exact cost. Okay. Example 3, I'm going to leave all this to you. Okay, just go through it and make sure you understand how do we apply the concept, and also how to interpret the result, and make sure you know the difference between marginal and the actual or exact additional cost. Okay, so I'm gonna just skip all this. Okay. Uh, Um, this would be a good because we have a graphical representation. Okay, graphical representation. So our revenue function in this case, you see this revenue function is a quadratic function. Quadratic function. So that's why we have the inverted U shape. Inverted U shape. So this is the actual revenue function, and this is a linear cost function. So our cost function is linear. It is a straight line. So it starts from 7,000, which is our y-intercept, and goes up. Okay, and goes up. So whenever cost is higher than revenue, we incur loss. We incur loss, and whenever revenue is higher than cost, we we enjoy profit. Okay, we enjoy profit. Okay. And these 2 points where revenue equals cost, so this is our break-even points. Break-even points. Okay. Um, and our profit function, so we can also derive a profit function by simply subtracting the cost function, this is our cost, from the revenue function. Okay, this. So please go through the example on your own, because I believe it is simple enough. It's not that complicated. So this is another concept of this. In cost, we also have average cost. Okay, average cost. So what is the average cost? We simply take total cost, okay, divided by quantity. So there is a typo here. There should not be a bar sign. This is what we call bar. Okay, so this is basically um, total cost divided by number of unit, total unit, where X is our total unit. And we always use the bar sign. This is what we call as bar, C bar. Okay, C bar, C bar. Marginal average cost, okay, would be when we differentiate the average cost with respect to X. Okay, respect to X. So similarly, for revenue and profit, we can do the same. Okay, so take note, there is no bar sign here. This is, so to find average revenue, we simply take total revenue divided by quantity. And to find the average profit, we take total profit divided with quantity. Okay, and for all this average function, we can always find the marginal average. Marginal average. So this example, so if you want to find the average cost per unit, if 1,000 dictionaries are produced, so remember what is the definition of marginal of average cost? C of X, C bar of X equals C of X divided by X. So if we have 1,000 dictionaries, what is our total cost? So C of 1,000 equals 20,000 plus 10 multiplied by 1,000. This is 10,000. So we have 30,000, right? Total cost. Now 30,000, to find C bar of X, we need to take 30,000 divided by 1,000. So we're going to have 30, okay? 30. So 30. So when 1,000 dictionaries are produced, the average cost is 30 each. Okay. Now, what is the marginal average cost? Okay, marginal average cost. So our marginal average cost, we need to basically take this function earlier. Okay, this 30,000 divided by 10,000. Okay, if you remember, and we differentiate it. Okay, we differentiate it. Okay. Um, So based on this, I simply find the average cost directly. I did not find the average cost function. Average cost function. So we can do that. No worry. So let's say we have uh, originally we are given with, go back to the, so our C of X was given as 20,000 plus 10x. 20,000 plus 10x. And our C bar of X is simply C of X divided by X. So we simply have 20,000 plus 10x divided by X. So this will give us 20,000 divided by X plus 10. Or if you want to write in a direct way but not elegant, okay, 20,000 X to the power of negative 1 plus 10. Plus 10. So this is our average cost. So from here, we simply need to find the derivative. So C bar prime of x will give us, so this is in the denominator. So this is -1. So -1 multiplied with 20,000 will give us -20,000 x to the power of -1 minus 1 give us -2. And 10 is 0. Okay, so we have -20,000 divided by x squared. Okay, so now we simply substitute, put this 1,000 here. So we're going to have c bar prime of 1,000 equals -20,000 divided by 1,000 square. 1,000 square. 1,000 square. Can I just need to erase this? Thought I can change. Yeah. Okay. So square. Okay. So this will give us negative. So use your calculator, negative 0.02. This is the marginal average cost. So how do we interpret this? So when we already produce 1,000 dictionaries, so each additional dictionary, okay, that we produce will reduce our average cost or our per unit cost by about 2 cents, right? In economics, usually when we do mass production, when we produce more, so the cost, the share of cost for each additional unit will go down. The average, it will become cheaper. Like when you want to order, I don't know, t-shirts or printing your books and something, 10 units, the average cost will be higher compared to when you book for 1,000 unit. Of course, total cost will be higher, but the average cost will be cheaper. If you order by a larger amount, the cost, the average cost will be lower. Okay. Um, so can we use the previous results to estimate the average cost per dictionary? Okay, if 1,001 dictionaries are produced, of course we can. So we already know the average cost for 1,000 dictionaries is $30 each, and the marginal average cost is -2 cents. -2 cents. So the average cost per dictionary for 1,001 dictionaries will be the average for the 1,000 plus the marginal average cost. Okay, plus the average marginal cost. So if we were to change our dictionaries from 1,000 to 1,001, so we're going to have a new average cost, isn't it? We're going to have a new average cost. Okay, and logically it should be cheaper, right? Because 1,001 is greater than 1,000. So if you were to add one more dictionary, your average cost would go down from $30 to 29.98. Okay. So please beware that marginal average cost function, in order to find it, first you need to find the average cost, number one, and then you need to differentiate the average cost function to find the derivative. So that derivative is the marginal average cost function. Okay. So there are two interpretations for the marginal cost function. The first one, the derivative. The derivative is the instantaneous rate of change in the cost function. And number two, it is an approximate of the exact cost of producing the one more additional item. So there are two ways how do we interpret marginal cost. Okay, so previously you have been exposed to this. We have discussed this a lot, right, on this concept of derivative. So marginal cost can be interpreted as the instantaneous change, the change in the cost that happened instantly. And now there is another concept, okay, where marginal cost can also be interpreted as the approximate of the exact cost of producing one more additional unit. Okay. But this does not apply to the marginal average cost function because it is not marginal cost. It is the marginal of the average cost. It is basically the change in the average cost. Average cost. So that's basically the end of this part, this section. Okay. Um, So this brings us to the next chapter. Okay. So this is all about additional derivative topics. Just open the correct slides. Okay. Additional derivative topic. So we start with this application. Okay, application of constant E. What does E stands for? Elephant. Okay, exponential. So E is an example of an irrational number. It is an irrational number. Okay, and it is particularly useful for both exponential and logarithmic functions. Okay, so we have already defined the exact value of E, which is 1 plus 1 over n to the power of n for n that is sufficiently large. Okay. Now, in order to find, so what is that rational number? We are applying actually the concept of limit. The concept of limit. Now, as n goes to infinity, this value, this term will basically approaches a constant number. A constant number. As n goes to infinity, this number approaches a constant number. Okay. As n goes up by a bigger and bigger amount, by a bigger and bigger value, this number basically converges or stabilizes. Okay, stabilizes into a constant, a real number. Okay, constant real number. So you can see the number will not go for it. I mean, if you make n to be bigger, so you're gonna basically find that the value of this E is 2.7173. Okay, can go all the way. So this is the number E. So how do we, so let's see an example of the application of this irrational number E. So let's say we are interested to investigate compound interest where P is the principal, R is the interest rate, okay, in percentage, and T is time in years, and M is the number of compounding periods per year. And finally, A is the amount realized at the end of the period. So we have five notations that you need to know. P, R, T, M, and A. Okay. Now, simple interest. So A, which is your amount that you get at the end of the time period, okay, is given by the principal, the amount of investment, your actual investment, multiply that with the interest rate, R, and multiply that with time in years. Because R is the interest for annually. So the longer that you put your investment, so obviously you're gonna get more interest. So your return gonna be higher, the amount that you realize. Now compound interest is given by this formula. Okay, by this formula, where the principal of your investment is now being multiplied with the annual interest rate divided by the number of compounding periods per year. And then this whole term, we make it to the power of T, the time in years, multiplied with the number of compounding periods per year. Because some investment would give you the interest periodically. It's compounded, okay, per year. It doesn't mean that you only receive it once every year. But some investment may give you twice a year, or 4 times a year, or every month. Okay. And then we have the continuous compounding, where your actual return, okay, is given by the principal that you invested, okay, and we multiply that with the irrational number E, okay, to the power of R multiply with T, okay, R multiply with T. If you resubstitute this E with the original this equation, and you will see that the definition really makes sense. Okay, so let's see this continuous compound interest formula. Okay, is given by this formula. These are all explanation. I'm gonna leave this to you. Okay, I'm gonna leave this to you. So if we were to apply the compounding interest, this is the simple compounding interest formula previously, isn't it? So let's say what if this happened continuously? Let's say you did not take out your money. If this were to happen continuously, that means that with many compounding periods, so we have where m approaches infinity. So within that 1 year, you receive the investment is giving you interest, in many compounding periods. Okay, in many compounding periods. Um, so let's try to simplify this by applying the different theorems of on the limit. So since P, which is our principal amount that we invested, is a constant, so we can actually, I mean, the limit of P is P itself. It's a constant, right? Okay. So we can take P out. And then we want to basically simplify this. Okay, simplify this. So what we are doing is that we are multiplying, the power with 1. R over R. Okay, R over R. So then um, we simply find for period S. Okay, so let's say we simplify this term R over M. Okay, R over M to be 1 over S. In other words, we want to basically simplify this. So this is I'm no longer going to have this. Okay, so M over R is S. Okay, M over R is S. Okay, so this is my how I change this. Okay, I'm going to change this, okay, into this, and then I simply change S. Okay, I simply change S. Okay, um, so as S, so goes to so, and take note that we can separate these two terms, right? These two terms. Okay, we can separate these two terms, and this is what the the definition for E. Okay, if you compare this with the original, so what is E previously? It is the in the previous slides. Okay, this this is the alternative. So what is we simply replace S with 1 over N here. Okay, so this is what we have done here. And similarly, what we have done here is we replace that R over M to be S. Okay, so that's how we get the continuous compounding formula from the compound interest formula. If we were to have this continuously, if we were to receive this continuously, okay, so we're going to get the continuous compounding interest. Example, I'm going to leave this to you because it only involves basically substitution of the values. Okay, so it should be straightforward, I hope. Okay. So you just need to apply the right formula and substitute, okay, the values given in the question. Okay, okay. Now let's say what if we change the question a bit, rather than asking you what is the final return. Okay, in the previous question we simply ask you what is the final return after you invest that money. So let's say we want now let's say you know your principal and you know your target. Okay, so your principal is 5,000, and you know you want to, at the end of that period, you want to get back 8,000. And let's say the interest, okay, the compound interest is 6%. Now you want to know how long should you put your money there. How long you should put your money there. Okay, so we're going to start, basically we're going to apply this formula. So P is given, A is given, R is given. We need to solve for T. We want to know T. Okay, so we substitute all the values here. So can you find the value of T? Of course you can. Of course you can. So after we substitute all this, in order to get rid of E, what should we do? We simply take the natural log of E. Okay, when we take the natural log of E, we put natural log on both sides. Okay, so what is the natural log of E? It equals to basically um, 1. So we take this. So you know that in logarithm you can always basically bring the power to the front, right? So if we have ln the natural log of E 0.06 t equals to 0.06 t ln of E, right? Okay. Oh, my handwriting is just try to, okay. So this is ln of E. And what is the natural log of E? It is 1, equals to 1. So we have 0.060 on the left hand side. And how do you find this value? Simply use your calculator. Okay. So let's say we want to solve for t, so we divide this. Okay. So you need to find the value. So natural log of 1.6 divided by 0.6 will give you 7.83 years. So this is the trick. How do we want to get rid of the irrational number e? We always put the natural log, and then we can bring the power to the front, and natural log of e will give us the value of 1. Okay, so that's why this irrational number e is very, very useful. Um, all other examples, I'm gonna basically leave this to you because it basically involve the same applications. So if you have any issue or any problem with understanding the examples, please let me know, because what you need to do is simply you need to substitute the values with the information given in the question. Okay, in the question. Okay. Um, we already basically finished this the first section of this additional derivative, and so this is the a more advanced formula or shortcuts for more advanced functions. So if we need to find the derivative that involve exponential and logarithmic functions. Okay. Um, so let me just, it's already 12:30, so more or less about 1 hour. I think maybe we should just stop here. I mean, with regard to new topics. So today what we have done so far is simply applications. Okay, applications of derivative. So we have done marginal cost, marginal revenue, marginal profit, as well as this continuous compound interest application. Okay, continuous compound application. So, so I'm opening the floor for any, I don't know, any question or any sharing, and expect to have your sixth quiz soon. And I plan to give you your take home test next week. Okay.
Sir,
Yeah.
which topic will be covered in the test?
Okay. Which topic will be covered in the first take home test would be until what we have discussed today. From the first day of class until what we discussed today.
Okay,
Mm.
and what about the time window?
The time window, I will give like what I have told you earlier at the beginning of this month. I'll give you about 1 week, right? But every day I'll give you a different question. What my plan is, I want to give you like 3 or 4 questions per day, and you are given a 24 hours window to do them. So your test one would be 25%. So 25%. So let's, just to make the calculation easy. So let's say I give you a total window of 5 days. So every day, 5%, 5%, 5%, 5%. So one day, maybe one question that worth 5 marks, or maybe two questions or three questions, and you have a window of 24 hours, okay, to submit your answer to that two or three questions daily.
Okay.
Doable, right?
Yes. We need to scan the answers.
Yeah. You need to scan the answers if you have a scanner, or if you have your, just like some of you have been, very good at this showing your workings. I mean, although sometimes I need to apologize. Sometimes I may respond a bit late, but some of you have been sharing with me your answers to the questions. You showed me your workings. Some of you have very good photo taking techniques of your answers. You share them with me. So those are what. It's just that I will also give you a cover page, so that whenever you set for, because the test, I mean, we need to make it a bit more formal, so there'll be a cover page, a standard cover page, and after that you can just basically write your answers anywhere that you want, and you have to submit them to me for grading through iTaklim. iTaklim can accept both PDF as well as photos, photo files, right? So you just take them, and I mean, take photo of them nicely, yeah. I mean, and upload them. Okay. Anything else? Mizanur Rahman, you have
Yes, sir.
anything to say? You are at the beach or what?
So, is it the same thing like we did in the quiz, or you will give a question, we have to complete it by 24 hours and submit it?
You have to complete it within 24 hours.
Or that means you will give us a question, so we download it and solve it and send it to you.
Yes, through
Oh,
iTaklim. The answer submission have to be through iTaklim.
okay, sir.
Okay. Unless if you have problem, please let me know. I mean, if you cannot submit through iTiling and whatsoever, you just alert me through WhatsApp, so that we can discuss how to solve it.
Okay, sir.
Mm,
Thank you, sir.
welcome.
Sir,
Yes.
we could practice for the test from the book only, or there is something more we need to practice from it?
I think the chapter exercises are good to prepare you for the test.
Okay.
Yes. So no more question. Okay. Yeah, I mean, I hope no more question means it seems that the materials are simple enough. It's not that complicated. Mathematics require you to basically be independent. You need to, if I mean, you have to assess your own capability and do the necessary things. I mean, do the exercise. If you think you are not good enough, perhaps you need to do more exercises compared to your colleagues. But I'm going to leave this to you, and I'm always open. Some of you send your answers in the middle of the night. Also, I mean, I don't mind, but please give me some time to find the solution. The next day. Um, so um, so I think that's all for today. Thank you for your time. Inshallah, we'll meet again next week. So expect your quiz tonight or tomorrow night. Inshallah, I'll prepare them, and please, I mean, try to score the full marks for the quizzes. Okay. So that's all. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Salam. Thank you, sir.
Yes, sir.
Thank you, sir.